quite a few names that I recognize. And so thank you all for joining us, but mostly thank you very much to Colin Rice, who's giving us our talk today. Earlier on, we did a bit of a test run, and I was really indulged and really wanted to carry on listening. So I'm really looking forward to this. Just as a quick, brief introduction, Colin Rice taught high school mathematics in Zimbabwe for 8 years before moving to South Africa in 1984. He's been actively involved in many aspects of the Southern African drilling industry since then. He was the founding partner in SA Mud Services, then later Sam Chem, and he was the managing director of professional diamond drilling equipment for 11 years when the company was acquired by Atlas Copco. In 1995, Colin and his business partner launched Borehole Survey and imported the very first electronic borehole survey tools into the country. Borehole Survey was the first company in sub-Saharan Africa to utilize the state-of-the-art electronic survey tools and the successful application of electronic survey technology. Colin has always had a keen interest in improving the understanding of drilling principles through training and was responsible for setting up the National Diploma Drilling Practice course at the Technikon SA. He's been delivering drilling and exploration-directed courses at a number of institutes and in a number of Southern African countries for the past 20 years. In 2017, Colin Rice Exploration Training Services proudly launched the Drill Safe, the Southern African Drilling Industry Safety Forum, and Colin is the driving force behind Drill Safe, which aims to improve the ability of people involved in the drilling industry to effectively identify hazards on drill sites. So after all that great credentials, Colin, I hand over to you, and I'm really looking forward to this.
Thank you, Sarah. Thank you very much indeed. That's very kind of you. Guys, thanks for joining us today. Thanks for taking us time off your I'm sure your well-earned lunch break. A little while ago, Sarah Nolene got hold of me and asked me if I'd put together a talk for one of these lunchtime sessions. I know how successful these sessions are. People really, really enjoy them. And I just finished a bit of work with a mining company where a couple of things sort of became apparent. And I thought, gee, it would be a really good idea, just rather than talking about some of the more fundamental parts of the drilling industry, is to talk about an aspect of safety that I think is very often overlooked. And that's the role of procurement departments in safety. I'm very lucky. I do a lot of safety work with quite a number of mining companies. And I've, in the last 5 or 6 years, I've started to do a lot of tender evaluation work, designing tenders and helping mining companies to evaluate tenders. And I've learned a few lessons through that. And what I want to try and do today is maybe just share some of those with you, some of the thoughts, the experiences I've had. And I'm going to show you a little model I've created that if any of you are involved in any tender work at any point in time, it might be a little trick that you might want to remember. So let me just get this thing going. Okay. So just to kind of set the scene a little bit, there's no question that exploration drilling is the most hazardous activity that takes place on any mine on any day. There's no doubt about it. And I don't say that lightly. Exploration drilling is a very, very hazardous occupation, very hazardous activity, and there are many, many, many hazards associated with an exploration drilling operation. About 10 years, maybe 11 years ago, mines in South Africa started to become more aware of exploration drilling. Back in the good old days, exploration was done in the bush. Nobody ever saw the rigs and nobody cared about them. And about 10, 11 years ago, they became very, very much in focus. And mining companies particularly over the last 3 or 4 years, have pushed really, really hard for exploration contractors to upgrade rig fleets, to train people better, and to bring in all sorts of innovations and automation to make drilling safer. There's been a big swing. And in this little picture on this slide is a rig, a fantastic drill rig run by one of our local contractors, drilling for one of our major mining companies, fully automated, computer-controlled drill rig, operated from a remote control cabin, an air-conditioned cabin. It acts as a Faraday cage as well in case of lightning. Fully hands-free, absolutely fantastic drilling machine. We, in fact, in this country have got the highest density of what I call new technology drill rigs. We've got the highest density than anywhere in the world. And I don't make that statement lightly. There's nowhere in the world where we've got as many of these drills operating in one location. So we've got some really, really good stuff happening here in South Africa. But even with these new technology drills, exploration drilling is still extremely hazardous. And anybody who's been involved or has had an accident on their site will know that it has a massive impact for a mine and obviously for the contractor as well. So safety is a really, really big issue. So if we look at the relationship, how does a contractor and a mine, how does their relationship work, and why am I telling you all of this stuff? In any relationship between a mine and a contractor, it's all based on a tender. It's based on a contract. And so the process would be very much as I've shown it here. You'll have a tender being developed, and a tender generally is in two parts. You'll have the technical side and the commercial side. The geos will get involved in the technical specification, and the procurement department or commercial department will generate the commercial and the legal aspects. Those will go together. They'll become a tender document that's issued. Contractors will then prepare their bids. They'll prepare their submissions, submit them to the mining company. The mining company will then evaluate those bids. And then based on whatever their criteria are, and that's what I want to talk a little bit about today, whatever their criteria are, they will then award the work. The contractor will mobilize to site and the work will begin. And that's the typical flow that happens. And from a safety perspective, the legal responsibility for safety, and when I use the term legal, I mean it. In South Africa, because of our Mine Health and Safety Act, we have very, very stringent legal requirements in terms of safety for any exploration or mining work that's done. And so the legal safety responsibility basically starts once that contractor arrives at the mine gate, once he wants to get his rig onto the mine to start working. And then that's all controlled through, any of you who know anything about the Mine Health and Safety Act will know that we have different levels of responsibility. We have a hierarchy of appointments, legal appointments that we have to make in terms of the Act. And so we have different people responsible for different layers of responsibility. And what I've come to realize is that maybe we start that responsibility too late, I beg your pardon. And I believe that we need to start looking at safety responsibility at tender development stage, and most certainly at the bid evaluation stage. I've been involved in several projects where this was not done, and the project scope was poorly defined. The bids were maybe poorly evaluated, and it's now a nightmare. It's very, very difficult. The contractor is not geared up for the type of work that is being done. There's several examples I've had in the last 4 or 5 years of this sort of thing, and that can be avoided if we get the procurement guys involved. And that's, as I said, what I want to try and chat a little bit about today. So I believe safety responsibility should start right at that early stage, right at the stage where we develop the tender, and particularly we evaluate the bids. And I'll show you a little trick, a little model that I've created that might help you to understand what we mean by them. And then the second point we must also remember is that once the work begins, the contractor's procurement department has an absolutely critical role. I'll give you some examples of that just now. This is often overlooked. And I believe that this should be built into the tender specification. And you'll understand what I mean in a couple of minutes when we get to that part. So just to further set the scene, over the time I've worked in the industry, and particularly in the last few years, the work I've done, there are two principles of business that rule exploration drilling, and well, in fact, rule all contracting. It doesn't have to only be exploration drilling. And it's really important we understand these. The first principle is that profit is the reward for risk. In other words, if you, in your tender specification, you are asking the contractor to take more of the risk than you as the miner are prepared to take, expect higher prices. The greater the risk you ask him to take, the higher the price will be. So don't be surprised when guys come with crazy prices because you've asked them to drill directional holes to 1,000 meters, and if you don't hit a target, I'm not going to pay you. He's going to lather you. He's going to ask for millions of rands to do that work because he's taking all the risk. The second principle, and this is the most important, is that if a contractor is not making a profit, he cannot perform on site. Think about that for a second. It doesn't matter what business. It has to be a contractor. A hamburger store can't perform if they're not making a profit. Every business has to make a profit. And the big question is, how much profit should the contractor make? And very often we tend to think, in many businesses in South Africa, we think that making a profit is immoral. We think that it's bad that companies make a profit. In a contracting situation, he has to make a profit. And I argue in a lot of the courses we do, in a lot of the courses, our online programs, other training programs we do, where we talk about the economics of drilling, I say to geos, I say it's your job to make sure the contractor makes a profit. And by that, I mean, don't stop him for frivolous reasons. And I must put a rider in there. If the guy's a bad contractor, he shouldn't have got the work in the first place. So you've got to balance. If he's a good contractor, do not stop him working. Help him work so that he can make a profit, because if he makes a profit, he will perform, he will give you what you want, and he will do it safely. Because what happens is if he loses money, if he's not making money, he will cut back on costs. There's only two elements to a contract, revenue and cost. And if you can't increase your revenue, the only way you're going to survive is to reduce your cost. It's very, very simple. And when he cuts back on cost, he's going to cut back on training. He's going to cut back on people who may be critical parts of his business. He'll cut back on maintenance and spares. He'll take shortcuts to repair equipment and so on. And all of that means your safety risk increases. It just gets bigger and bigger and bigger. And I can tell you that in many of the accident investigations I've been involved in, sub-economic rates has been a contributing factor in many of them, because the contractor just has not made money. He has to make money. The other part of this is that I believe that these safety imperatives, this massive emphasis on safety, it means that companies must change, and many mining companies have done this. They've changed their procurement strategies from giving work to the cheapest contractor to giving work to the best contractor. But the problem is, how do you do that? How do you decide what's the difference between a cheap contractor and the best contractor? So what I believe mining companies must do now is, and as I say, many are starting to do this, many do this all the time now, is no longer ask, are we paying too much? But rather ask, are we paying enough? If we're paying too much, we can always go back and negotiate a rate down. But if we're not paying enough, we're in trouble. We're going to have a nightmare of a project. So to answer those questions, a mining company needs to know what it costs to drill a borehole. And there's no simple answer to that. There's no, I can't tell you that it costs you 758 Rand to drill a meter of platinum. It means there's a million factors that come into that. So you've got to have a model that will allow you to calculate, a little should cost model that allows you to calculate what it should cost you to drill. And that's what I want to talk to you about today. The basis of the model is very simple. The cost to drill for most drilling contracts, the cost to drill is directly related to the time to drill. So if we can model how long it takes us to drill a borehole, and if I can then work out what it costs me to drill the first meter, I should then be able to work out a model. I should be able to generate a curve for myself that will tell me roughly what it will cost me to drill a borehole. To do this, I'm going to use two little examples here. Okay, let's assume we're drilling a reverse circulation hole. You'll all know what we mean by reverse circulation RC borehole. When we drill an RC borehole, we have a downhole hammer on a drill string with a compressor and a hammer, and we've got two elements of time in drilling a borehole. The first element of time is our actual drilling time, our penetration rate time. I'm going to drill at a certain penetration rate. I'm going to get to a point at which the bit on the hammer is dull, it's blunt, and I need to resharpen it. So I've got to come out the hole, I've got to pull the drill string out the hole, resharpen the bit, go back into the hole. I can then drill the next interval until the bit is blunt. I've then got to pull, resharpen the bit and lower. I'll drill the next interval and so on. Now I can model that. It becomes a little arithmetic progression. And as Sarah said, I used to teach maths. So things like that I enjoy, and you can model it. Very, very simple to do that. And you'll end up with a little curve that looks like this, where you've got your penetration time, your drilling time, your rod pulling time, your drilling time, your rod pulling time, your drilling time, your rod pulling time, and so on. If you look at a wireline borehole, a diamond drill hole, a core drilled hole, where we're drilling with a wireline drilling technique, we've got one extra element of time here. I've still got my penetration time, and I will drill and drill and drill and drill and drill until my bit is finished, and then I'll pull and lower to change my bit. But in between time, because I'm drilling wireline, I'm going to advance. My core barrel is going to be full. I'll lower the overshot, pull the inner tube, clear the inner tube, drop the empty inner tube back in the hole. I'll drill the next bit of advance until my core barrel is full, drop the overshot, pull the inner tube, clear the inner tube, lower the inner tube. So I've got all of these shorter spaced intervals. And if I model that, it looks something like this. So I'm going to have all of these little advance, retrieve the inner tube, advance, retrieve the inner tube, advance, retrieve the inner tube. And then every now and then, when I need to change my bit, I'm going to have a bit of time there where I've got to pull and lower. And obviously, the deeper the borehole gets, the longer those pull and lower times become. Now, as I said earlier, it's very easy to model that mathematically, very, very simple. And if everybody really wants to get bored, and if you've never had enough of maths as a geo, I never met too many geos who like maths, the ones that I was at varsity with. But if you are slightly demented and you want to learn a bit more about it, I'd be happy to show you how you would model these things. But what you would land up with is a curve. It's a quadratic curve. So if you take your different elements of time and then you sum them for certain depths of hole, you get a quadratic curve. And that's very important for us to understand, because drilling cost is not a straight line. It is a curve. And it's a quadratic function. It's a very gentle quadratic function, but as boreholes get deep, particularly when you start getting into sort of 1,000 meter, 1,500 meter, 2,000 meter holes, this kind of analysis becomes really, really interesting, and you learn so many things from looking at these curves. So the theory is this, guys. The theory is very simple. If I can generate, as I've done here, this blue line, this is my time to drill line. So based on the model, I have made assumptions about how quickly I can pull drill rods. I've made assumptions about what my penetration rate is. I've made assumptions about what my bit life is. I've made assumptions about how quickly I can lower my overshot and pull the inner tube. So I've made assumptions on those variables, and they can be very, very accurate based on empirical data. And I can now have got a curve. And if we assume that the cost to drill is directly related to the time to drill, if I can calculate what it costs me to drill the first meter of core, that very first meter, I can then basically mirror the time curve and generate what I call a cost curve. And our cost to drill should mimic this line. It should mirror that line. The big question is, how do I determine this y-intercept? How do I determine that cost to drill the first meter? And that's the second part of this little model. Based on a very simple variable cost model, most drilling contracts now are variable cost contracts. In the old days, we used to have fixed rate contracts, but we don't do those anymore. So we generally have what we call a fixed rate contract. So the easiest way to show you this is, think of a contractor having fixed costs and variable costs. And his fixed costs, he'll pay every month whether he's drilling or not. And the biggest element of cost there is rig amortization, his depreciation on his rig, the money he's got to pay to the bank to finance his capital equipment. Variable costs he only incurs when he's drilling. And those will be bits and rods and reaming shells and drilling fluids and so on. And the formula is very simple. It's very simple to calculate the cost to drill a meter of core. The contract will take his fixed costs. He'll divide by the number of meters he believes he's going to drill in that month. And that will give him his fixed cost per meter. And then he'll add his variable cost. So let's take a little example here. Let's assume a contractor's got fixed costs of 360,000 bucks a month, and his variable costs are 288 Rand a meter. And he believes, because he's read the scope of work, he understands the mine conditions, and he believes that he can drill 800 meters a month. So he will do his calculation like this. So he'll take the 360,000 divided by 800 to give him 450 Rand per meter fixed cost. He add his 288. So he will believe that his cost to drill the first meter will be 738 Rand a meter. And then obviously he will add a margin to that. And that's what he will bid to the mining company. And based on that, they'll either give him work or not give him work. So if we go back to what I showed you just now, we've got our green line there, our theoretical cost curve. And all I've done is I've shifted it up so that the y-intercept is now at 738 Rand. And what I can now do is I can superimpose on that the contractors' rates. Now, if any of you have had experience with this, contractors' tender documents always ask contractors to bid in depth intervals. So in this particular case here, for example, this contractor has bid, what is that, 800 Rand a meter for the first 200 meters, then about 950 Rand a meter for the next 200 meters, then about, what's that, 1,200 for the next 200 meters, and so on. And if you look at this now, if we assume that that green line is a true reflection of the cost to drill, then this little graph shows me some really interesting things. It shows me anything, I'm sure you guys will agree with this, anything above the green line is profit, and anything below the green line is a loss. So this contractor is riding pretty close to the wind here, because he's losing money towards the end of some of the intervals. So maybe he hasn't done his sums correctly. What this also shows you, I mean, this is just something I threw together. I'll show you something a little bit more realistic in a minute. But what this also shows you is this contractor is not very clever. If you look at your increments for every 200 meters, you can see how irregular they are. And it's one of the key things I look at when I get involved in tender evaluations. Is the first thing I do is I draw this graph to see what the contractor does. And as your depth increases, your increments have got to get bigger. It cannot be a static 10% or 30 Rand or 100 Rand. It's got to get bigger because your curve is a quadratic curve. And if you don't see that, that straight away indicates to me the contractor doesn't understand the cost of drilling. He doesn't understand his rates. So to show you how this can be used by a procurement department, by the commercial guys, these are just 4 examples that I've put together here. And each of these tells you a really, really interesting story. We've got exactly the same cost curve here, and 4 different contractors bid on the same work. Contractor A, I'm sure you'll agree with me, is going to lose dosh. he's in trouble. He's not going to make any money in this contract. Contractor B, well, if all the holes are less than 600 meters deep, he's okay. Once holes get deeper than 600 meters, he's in trouble. Again, now this comes back to where the evaluation's got to be done properly, because in this case, I don't even know what this was all about. In this case, the tender specification must say we're going to drill 52,000 meters of holes with an average depth from 400 to 1,200 meters, and we're going to drill 16 holes of 1,000 meters. We're going to drill 14 holes of 800 meters, and so on. Because with that breakdown, a contractor can look at this and he can plan his rates so that he can maximize his profit. He can make sure he covers his costs. So these two tell you some very interesting stories. Contractor C looks like he's got his ducks in a row. I think he understands what he's talking about. You can see his increments are getting bigger with depth, which is great. He's above the line constantly, so he knows what his costs are, and he will make profit the whole way through this program. Contractor D, if you look at contractor D, you might say, gee whiz, this guy's a bit of a crook. But in fact, I put this in because it tells you a little bit of a story. Contractor D is not actually bidding on the same equipment as these guys are. So all of these guys, A, B, and C, were using similar types of drill rig. Contractor D was using a very expensive, not quite automated, but you know what I mean, a hands-free rod handling, a really, really fancy drill rig. So you can't compare apples with apples because you haven't got the same apples here. But if you look at it in this context, you can see where the difference is. So this guy, contractor D, his cost curve wouldn't be there. His cost curve would probably be up there. It might start at 1,400 Rand or something of that nature. And that's because of the additional amortization, the depreciation that he has to build in for his drill rig. Now, if you look at this, many procurement departments on mines, which contractor do you think they would want to give the work to? Obviously, they would want to give it to A. But I believe that is, I believe it's crazy. You can't do that. You can't give it a contractor A. We know he's going to be in trouble. And what unfortunately happens is that the geologist on site, the supervisors, the port geo has to carry this can. Whoever's responsible for safety inherits that contractor, and you're inheriting a disaster. And so that's why I think it's a fairly neat little way. It's not hard to do this. It's very, very simple to do this. You now have got a way of looking at things and really comparing bids, really comparing what goes on. So that's a little tool that I think procurement departments could use. Now, what unfortunately happens, and I see a lot of this in going around the sites that I go around to. In the little picture I've got on the left here, you've got the blue hatched area represents the costs. That's the contractor's costs. And in this case, he's got his rates in there. We've got, which is represented by the little yellow shapes in there. And this contractor has assumed he's going to drill 1,000 meters a month because he's looked at the scope of work. He understands the mine. He knows where the issues are, and he's based his entire business on drilling a 1,000 meter borehole every month. And so the yellow area represents his profit. Now, I suppose the big question is how much profit is reasonable? Well, that's another 2-hour debate. We'll talk about that next time we have one of these sessions. How much profit should the contractor make? Really doesn't matter. Academic question right now. But that yellow area will represent his profit that he's going to make in this project. But then frequently what happens is what we've shown you on the right, where because the geo hasn't done their work or because the mine had a problem or whatever the case happens to be, he can't drill 1,000 meters and he only drills 700 meters. And the problem now is that this red area in the left-hand illustration represents his fixed costs. Those fixed costs have now got to be squeezed into a much smaller area here, if you understand what I'm trying to show you here. So all it means is the cost curve is driven up and his little yellow triangles become tiny little triangles. So his profit gets less and less and less. This is so simplistic, and I hope I'm not offending your intelligence by showing you something this simple. But it's as basic as this. And all that happens is this cost curve keeps moving up. It eats away at his profit. And as it eats away at his profit, his maintenance, his safety standards, his ability to repair equipment, to replace equipment goes out the window. And then the fun and games really start. Then our life becomes a misery. The second thing that happens is that sometimes costs increase. We live in South Africa where we've just had, I think it was yesterday, day before yesterday, we've just had a R1 increase in the cost of fuel. The impact on that on a contractor is significant. They use a lot of fuel. And all sorts of other things change. Our exchange rate changes. Our costs are never stable. I saw some costs the other day for some drilling equipment. I'm a little bit out of the commercial side. I don't keep myself up to speed like I used to. I was absolutely blown away at how much it costs to buy imported drilling equipment now. So all that happens here again is that cost curve is driven upwards, and that profit gets less and less and less. And this is where the procurement department have a role to play. Because when a contractor comes back and says, guys, geez, I'm in trouble, I'm not making any money because of this, that, the next thing, is mining companies must sit down and evaluate that. But you can't evaluate it unless you can do these things. If you've got these ideas, you can sit down with a guy and say, no, you're talking nonsense. Or you can actually validate what the guy is saying, and you can come up with a workable solution that will allow the guy to make some money and to make some sort of a living. So the other side of it, that's from a sort of mine side. From the contractor side, the procurement department has a critical role to play as well. And I'll spend 2 minutes on this, and then we'll sum up. Once a contractor's drilling, and again, I see this all the time. When a contractor's drilling, there are certain critical pieces of equipment that have to be procured from the right place. And very often what procurement departments do in contractors, they are rewarded by saving money. So if they can buy a hoist rope, if the proper hoist rope they should get costs 3,000 Rand, if they can get a cheaper one for 2,500 Rand, they will buy it because they don't know what the significance of that hoist rope is. And I see this all the time on drill sites, and it is a massive risk. It's an enormous risk that many mining companies don't even understand is there. Contractors don't understand it's there. So things like lifting tackle, anything that lifts a load, steel wire ropes, D-shackles, hoist plugs, adapters, there has got to be a policy. The drilling contractor must have a policy, a clear policy that says we will use this grade of rope, this grade of D-shackle, we will use hoist plugs from this manufacturer, and we'll only buy OEM made adapters. It's going to cost a little bit more money, but that is what our policy is, and that must be in place. Similarly with core barrels and overshots, those of you who know anything about wireline drilling, some of the geos will recognize this. I came across this the other day where a guy lost 4 fingers on a hand because the contractor bought lifting dogs. These are called lifting dogs. They fit into the overshot. And the lifting dogs did not match the spear point because he bought the inner tube assembly, this part here, he bought from one manufacturer, and he bought the overshot from another manufacturer, and they were not compatible. Very important to understand. The equipment we use is not standardized. Every manufacturer have their own drawings, their own specifications for that equipment. dimensionally there are variations, and these things don't necessarily match. And the only way you're going to stop that becoming a problem is by having a policy that says we buy from this company, and we will only buy from, we'll not mix up components from different manufacturers. And this is where it becomes really important. And it's something I drum on all the time with contractors. Very seldom do you get any positive response because they're all trying to save money. But this is something that mining companies too must be very, very aware of. So what I'm suggesting then is that in addition to what we said there about the mining procurement side, the mining procurement guys in the tender document must specify that contractors must have these policies for any critical component. So you can list them, very simple. It's a very short list. Any critical component must be sourced from an OEM, and there must be a rigorous balance, a rigorous audit trail to make sure that components are not mixed, that the right specification of equipment is purchased. Because if you don't, the implications can be serious. There was, just mentioned now, a guy, purely and simply because of a poor procurement decision, lost 4 fingers on a hand because an inner tube separated from an overshot. So just to summarize, so Nolene, I said I'd do 40 minutes. I'm going to go a couple of minutes over. We'll be done by 45, I promise. We cannot overemphasize how important safety is on a drill site or a mine. We know that. If you don't know that, then you'll learn that very quickly on a mine site. And I believe that safety starts, the whole safety cycle starts at tender development, and most certainly it continues through the contract award stage, the contractor evaluation stage, and the contractor award stage. And mines have to look at the best contract as opposed to the cheapest contractor. And most major mining companies have long changed their views on that, and they do that. Once the project is operational, it's very important for the guys on site. And obviously procurement people in mines can't do this, but they must be sensitive to the feedback from this. So we must look out for telltale signs of contractors not making a profit. It's very easy to see, I promise you. It's very, very simple to see. And those issues must be addressed. If a contractor comes back and says, geez, I'm battling, I'm not making money because of this or that or the next thing, we have to listen to him. We have to evaluate, make sure we got the right tools, evaluate what they say, and fix the issues if we can. So I'm suggesting as well, finally, that mining companies should insist in their tender specs that contractors have these procurement policies, these rigorous policies. Those policies must be evaluated. Part of the evaluation strategy must be to look at those policies and interrogate them and make sure they address the correct issues. And then once they're operational, make sure that those policies are followed. And then I think we can really start to ring fence and get a really good handle on safety in an exploration drilling operation. Okay, guys, that's me. That timing was pretty good. I said 40 minutes, Darlene, we're on 40 exactly. So that should make you very happy.
Fantastic.
Guys,
totally happy. Thank you.
You'll be happy when you go to Whiskey Creek. You'll have a wonderful guys, I don't know if there's any questions or comments, but I just thought I'd try and share that with you and give you something to think about over the weekend.
Colin, maybe I can jump off with a couple of questions.
Sure.
And maybe they're not so easy to answer, but in your experience, do the procurement departments have enough technical input, enough technical advice to make the decisions, or are we dealing with a bunch of accountants and bankers? And conversely, do our geologists and technical people in charge of drilling programs have enough knowledge of the company procurement processes in general?
Craig, those are two very good questions. I can tell you absolutely honestly, as I said, I'm very lucky. I've worked with some of the bigger mining companies in tender development and tender evaluation, and I can tell you there's a big shift. The procurement guys that I've worked with are good oaks. They're good guys, and they want to learn as much about the technical side as they can. And they are becoming, I think maybe because safety is such a big issue, they've become what's the word I'm looking for? I don't mean pliable, but they've become more sensitive to what the technical guys say. And so certainly, no, they're not just a bunch of accountants, but most certainly not. I've seen some really good and very effective procurement guys. And then, yeah, from the geo side, from the technical side, there's always a balance. The technical guys are responsible for safety. Procurement guys are rewarded for getting the cheapest rate. So if you can knock a contractor down in price, well, you've done well. But these two things, they're not mutually exclusive. They actually are very tightly wound together. So Craig, maybe in the old days, what you were saying there was right, but I certainly think it's moving in the right direction now. I certainly do think so. Anything else there? Have I gone quiet? Am I right?
Yeah,
okay.
maybe one more from me. I mean, you talk about fixed costs and variable costs. And I'm presuming that the increasing emphasis on safety and environment and health issues in general is adding to the fixed cost more so than the variable cost. Is that a fair statement to make?
Yeah. Where it comes, let me do something here. If you go back to this little thing here, where the problem comes is that your fixed costs, really, one of the biggest elements of fixed cost is your amortization of your drill rig. So if you've got a 15-year-old drill rig that you paid off 10 years ago, your amortization should be zero. If you've got an 11 million rand a remote control, hands-free rod handling drill rig with all the bells and whistles, your fixed cost, your amortization is going to be very much higher. So that's the one impact on fixed cost. The other is this one here, are your meters drilled. Because it's a very simple exercise here. The contractor believes he's going to drill 800 meters a month. So his fixed cost per meter is 450. If for some reason he only drills 400 meters a month, his fixed cost has doubled. It's very simple. And so you've got two effects that affect that. One really is the capital cost of your equipment, and the second is the number of meters that you can drill. I helped to mine the other day in a problem they were having, and it indicates how mines are reactive now. A contractor, in the tender spec, it said that they would be able to drill a certain number of meters a year. And so there was a hugely capital intensive project, massive amounts of capital. Halfway through the contract, there were circumstances in the mine that dropped those meters significantly. And he went back and said, I'm dying, I'm not making any money. And I helped them work out where they were, and they've gone back and they've adjusted the rates. And that's purely and simply because of this here, because the denominator got smaller. And so therefore your result gets bigger. I don't know if that answers your question, Craig.
Yeah, I think so.
Variable cost will change very little from one contractor to the next. A good contractor and a poor contractor will have very similar variable costs, but a good contractor will draw more meters in a month than a poor contractor, and that's where you'll see that difference in rate come in. If that makes some sense. I don't know if there's any other questions or comments.
Just a small comment from me, and you only just lightly touched on it now, Colin, but having worked with a number of different contractors, what I've noticed is that generally sort of the lower paid contractors take a lot longer to drill their meters, which sort of impacts on us getting to deadlines as well. So there's also that sort of bottom line that I'm not always sure that procurement officers or procurement staff take into account. With it taking longer, so does the actual company's costs as well, and that impacts on us as geos a lot. And that's what I've found particularly.
Yeah, absolutely. Absolutely. Look, a lot of very often, anybody who's worked on a mine will know that it's working on an exploration project away from a mine is much easier than working on a mine. Your time availability on a mine is tiny. I mean, you've got all sorts of, I've worked on projects in a 12-hour shift. The guys were lucky to actually have 6 hours drilling. All the rest of the time was fiddling around, trying to get into the workplace and getting through security and all sorts of other hurdles you'll overcome. So yeah, that has a big impact. But yes, Sarah, you're absolutely right. A poor contractor, a good contractor, you'll see it in production rates. Very, very definitely. You'll see it very clearly. And it does, yeah, obviously has a big impact on you guys. Big impact. Guys, anything else? I know it's a Friday, and I know Geos have probably got their corkscrews out already. I know Nolene has. So I don't know if there's any other questions or comments there, Sarah?
No, that was us really, just to say thank you so much for the talk, and I found it very, very interesting, particularly being involved on a drill rig as much as I have. So I really enjoyed it. So thank you.
Good, that's a pleasure.
Thanks,
Okay,
Colin.
with that, I'll close the meeting unless there's any going once, going twice, going 3 times. There's a comment from Shannon. Thanks for a great presentation.
Thank you, Shannon.
I see no more questions or comments, so I'll close the meeting now. Thank you very much. And this will be available on the GSSA YouTube channel.
Thanks, Greg. Thank you, Sarah. And thank you, Nolene. And thanks, guys, for attending.
Thanks, everyone. Bye. Have a
great
good weekend.
Cheers, guys. Bye.